As we start into day 2 on 6.1 homework, I want to go over one of the homework questions, number 4 here in particular. Let's do the expansion method and do -5 b to the 4th 3 times. Now, be careful. Remember yesterday we mentioned if we have a negative exponent, we have to move it to the bottom or the top of the fraction to get rid of it. If the number, the base number here, is a negative, that's fine. We don't move the -5, only if it looked like something like this, if it was 5 to the -1 power, or if it was x to the -5 power. That exponent here is the thing that has to be negative. The number itself can be negative, so don't move it to the bottom. All we have to do here is crunch it together. So I'm going to get out my calculator and crunch together -5 times -5 times -5, which is -125. After you've done the expansion, you're going to notice there's 4 b's, 4 b's, and 4 b's, and then you would count, and there's going to be 12 of them on your paper. So this here is the final answer. And again, my point is, it's okay to have a negative, what's called a coefficient in front of my variables. So do not move that part to the bottom. The other thing about negative exponents I want you to be cautious of is look at number 6. Now, we do have 2 negative exponents we need to get rid of. This e to the -4, and be careful, the d has the -2 power. That 12 is not connected to it, so do not move the 12. A lot of people are tempted to. Keep the 12 there. So let's just do the first step of rewriting. That's going to go down, and that's going to come up. So I'll have 12 e to the 6th f. I'm going to bring that e to the -4 up so it becomes positive. Then on the bottom I have the 4, d to the 7th, and f. That d to the -2 is coming down, so it's d squared. And let's simplify this one. If we do the expansion method on it over here, I'm just going to write it out a little more details on this side. We're going to have 12. I'm going to have 6 e's, 1 f, and then 4 e's. Then I have 4, and I have 7 d's, an f, and then 2 d's. Now for crossing off, it looks like I can cross off this f and that f. There's no e's or d's to cross off on the tops and bottoms. All I can do is crunch them together. So count how many there are. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have e to the 10th power. And d's, 1, 2, 3, 4, 5, 6, 7, 8, 9. d to the 9th. Now be careful, we do have 12 divided by 4 still, which is the number 3. So I'm going to put the 3 on the top because 4 comes out of 4 once. 4 goes into 12 3 times. So notice this 3 is on the top. I don't technically write the 1 on the bottom, so I'm just going to leave it like this, and that's your answer. Now I want to start our notes for day 2. We're going to try to apply Learning Objective B, which is the rules and the tricks this time. And we're going to look at a combination of let's expand it out, and then now let's come up with some shortcuts if I don't want to have to sit and expand it anymore. So this first one here, x cubed 2 times. In the expansion method, we would do x cubed and x cubed. Then we would write that out 3 times and 3 times. And what we're going to notice is you add them up and you get x to the 6th power. Okay. So what you notice is this. When you have just one variable, when it's just one base thing of an x, but the 2 exponents are right smack dab next to each other in this case, the shortcut you can do is to multiply them together. 2 times 3 is 6, which would get us this answer. Let me show you. On number 2, if we apply that, I would do 3 times 5 and say that that's 15. Well, I'm just going to stop and think about it for a second. If I do a to the 5th 3 times, and then the expansion method, I would have to write a to the 5th here 5 times, and I would do it for this one and this one. If you think about it and write it out expansion method, you count them, you're going to see 15 A's. So it does work. Now be careful with number 3. If you use the trick, that exponent has to clearly, this 3 and 3 touch, But the 2 actually has an exponent to it. It's the number 1. If you don't see an exponent, it's raised to the first power. So this 3 would have to touch that also. So what I would write is 2 to the power of 1 times 3, which is 3, c to the power of 3 times 3, which is 9. Now be careful, I am going to simplify. This is a number. 2 cubed is 2 times 2 times 2, which is 8, c to the 9th. And again, in the expansion method, if I did it, you'd have to be careful because this whole thing has to be repeated 3 times. That's why we see the 2 happening 3 times. Okay, the second trick, let's do expansion. I'm going to do x to the 4th, x 4 times and x 3 times, and then 3. To crunch it together, we're going to count and notice that there's 7 x's, so it's x to the 7th power. Now the trick in this case is if you have the base of x's here and then the base shows up again. If they're separated with those 2 x's or the bases, in this case, you're going to add the exponents. So 4 plus 3 is 7. So let me show you. On this one, we have 3x squared y to the 5th, just one time, by the way, don't have to repeat it, and x cubed y squared just one time. So if I wrote it out without the parentheses, it would just look like this. And if I think of the expansion method, x would happen twice, this x would happen 3 times, so there would be 5 of it. Well, just add it. 2 plus 3 is 5. The y's, this would happen 5 times, this would happen 2, so you're going to add them, you don't multiply. 5 and 2 is 7. And then we always put the number in the front, it's called a coefficient, and it's just a single 3, so that's our answer. Number 6 is very similar. Again, if we look at getting rid of the parentheses, this is to the first power, it's just not written that way, so you could write it like this first if it helps you see it better. And crunch everything together. Remember, this is multiplication, so when you see 4 and 7, don't add them and get 11. 4 times 7, use your calculator, is 28. The a is going to be next. It's a to the 5th. If I write that out longhand, there's 5 of them. A to the 9th, if I write it out, there's 9. When you expand it, you will see 14 of them when you count, so it's a to the 14th. The last one is just a b squared because there's only one of those, and that's our answer. Trick 3, let's do the expansion first. So on here, m to the 4th would be 4 m's. The bottom there would be 3. Now we're able to cross some stuff out. That 1 m, those 2, these 2, and we would be left with a single m. Now the trick here is when you have the same variable, so in this case m on the top and m on the bottom, what you do to their exponents is you subtract them. You always take the number on the top first minus the bottom. So what I would do for simplifying, I would say it's m to the 4 minus 3 power. 4 minus 3 is 1. M to the first power is just the number, or the letter m. So if I don't want to use expansion, if we look at number 8, what I could do is say, okay, those are 2 a's, so I'm going to do 2 minus 1. And then these c's match up, and I do the top number first, so it's c, 5 minus 3. If you simplify, 2 minus 1 is 1, 5 minus 3 is 2. What I would type into Schoology would be a, c, caret 2. And if we expanded it out, think of it this way. There'd be 2 a's on the top and 1 on the bottom. When you cross those off, there's 1 on the top, which is this guy right here. Okay, number 9 has a couple things going on it. First thing you might want to do is, there's a couple approaches, is I think I'm going to combine, I'm going to use the rule from the last slide and combine these 2 x's on the top. Because if you look at this problem, there's actually 3 sets of x's. Our final answer has to have 1 group of x's, so we have to take care of that. I'm going to do these 2 first. If I expand it out, it'd be x 4 times and x 3 times. So it's 7. I'm just going to add them, remember? So 15, x to the 7th, y squared, over 3, x squared y. Now I can tell there's more work to do. These 2 x's need to be crunched together. These 2 y's need to be crunched together. So I have 7 x's on the top and 2 on the bottom. Remember on that you subtract. 7 minus 2 is 5. Here I have 2 y's. This y doesn't have an exponent, it's 1. So 2 minus 1 is 1. And before you think you're done, always check the number. In this case, can 5 divided by 3 be simplified? Sure. You can either pull a 3 out of here and get 1 and a 3 out of here and get 5. Or do 5 divided by 3 is 5. So my final answer, I would do 5, x to the 5th, and then a single y. Trick number 4 and 5, we've kind of talked about trick 4. It just means get rid of negative exponents. So this is nothing new. So on number 10, notice it's a to the negative 2. So this a to the negative 2, I'm going to move down to the bottom, which will get me b cubed over a squared. Now, there's one b and there's one a term, so I'm actually done, and there's nothing else to have to be done for that problem, so I'm going to stop. Number 11, I have 2 negative exponents to get rid of. This one here, this one here. So I'll move the y down, move the z up, and rewrite it. So x to the 5th, bring that z up, z cubed, plus y cubed on the bottom, and this y comes down, y squared. Now, if you look at it, there's one x, one z, but 2 y's. So the x and the z are done. There's one of each, so that's the done. That's done. Either expand the bottom out, either write out that there's 3 y's and 2 y's, or use the tricks. 3 plus 2 in this case, so it would be y to the 5th power. And then number 12, the one thing we need to get rid of here is the e. This is e to the negative 3, so let's bring it down and rewrite it. So I have 6 d squared over e to the 4th d squared, and then e to the positive 3. Now in this case, the number 6 is fine. There's only one number in the whole problem, so there's no other number to write. However, I have a d and a d, so those have to be crunched together. Now there's 2 things you could do here. You could either realize d squared and d squared cancel each other out, and you can just cross them out, which is fine. Or trick number 5 says you would do this. You would take 2 minus 2, so you would write d to the 2 minus 2 or 0 power. Okay. But remember, the other method you may have done is just cross the d squareds out. If you cross them out, they're gone and they're not there. So that's the normal trick, but this trick 5 says you do 2 minus 2, which is using the subtraction. So d to the 0 power actually equals 1. Any exponent or base to the 0 power becomes the number 1. So we'll come back and clean that up in a second. Now let's do the bottom. The last thing we have is e to the 4th and e to the 3rd. Add those exponents, we get e to the 7th. So if you do have a final answer that looks like this in the blue, remember anything to the 0 power would become 1, so the answer is just 6e to the 7th is what we would type in. I want us to look at 2 more involved examples and just use our tricks this time versus expanding. So this first one here, first thing I always like to do is get rid of the negative exponents. So I'm going to get rid of that negative and bring it up to the top. Now be careful that a only has the negative 2. This little 2 doesn't. If it had been written like this, in parentheses, 2a to the negative 2, then you'd have to move the entire 2a to the top. But in this case, it's just the a. So when we rewrite it, it's going to look like this, 10 a cubed b squared a to the 4th. This new a is coming up and becomes positive. On the bottom, we have 2b. Now, I'm going to deal with the a's first. They're all on the same top, but there's 1, 2, 3 sets of them. They have to be crunched together to become one set. Remember, if you do expand them out, you would have 3, 4, and 2, or just add your exponents. 3 plus 4 plus 2 would be 9. On the b's, we have them on top of each other. They're being divided, so you would subtract. Remember, this is just b to the 1st. So I'm going to take 2 minus 1. 2 minus 1 is 1, so I put that there. Then I'm going to stop and pause and check the numbers and realize I have a 2 on the bottom and a 10 on the top. If I take, I can take 2 out of both. So 2 divided by 2 is 1. 10 divided by 2 is 5. So I have a 5 on the top and a 1 on the bottom. Typically, we don't write that 1. So our final answer would be 5 a to the 9th, and a single b, because we don't, again, typically write exponents with a 1 on there. The last problem, let's see what we can do. Again, I'm going to start with my negative exponents. I'm going to move this, this, and this, and just rewrite it. So we have 3x to the 5th, z to the 4th. The z negative 3 comes up to z positive 3. At the bottom I have 12, y to the 10th. The y negative 2 is coming down to become positive. The x negative 2 is coming down to become positive. Now on here, if I look at the variables, I do have 2 sets of x's, 2 sets of z's, and 2 sets of y's, so I do need to crunch them together. I'm just going to start with the x's. Well, I'll start with the z's here, actually. Here's 2 z's right next to each other, which is going to give me 7. You add them. Here's 2 y's on the bottom, so I'm going to keep them on the bottom. There would be 10 and 2, so there would be 12. Then I have an x to the 5th and an x squared. If you expanded them out and crossed off, you'd be left with 3. We're going to do 5 minus 2. 5 minus 2 is 3. The last one, be careful. 3 divided by 12 does not become 4. What you do is you take 3 goes into 3 once, 3 goes into 12 4 times. Notice where the 4 is. It is on the bottom. So keep the 4 on the bottom. Do not put it on the top. There is a 1 up there, but again, technically we don't write that. So what I would write as the final answer would be x cubed, z to the 7th, 4, y to the 12th.